Welcome friends to Power Plant Guru YouTube channel. Friends, I am a mechanical engineer with around 20 years of experience in the field of power plant, and I used to create small fundamental knowledge series videos for power plant engineers. We also run doubt clearing sessions on weekends. So if you want to reach us, you can reach us through comment section and join our weekend classes. Let us continue to watch our today's video. Yeah, welcome to new video of Power Plant Group. I was getting request to create this video from many of users, so that is why we have picked up this video. And we are going to talk about impact of ambient air temperature on gas turbine output and the performance. So we can take a case, for example, where you have a turbine at a location where the minimum and maximum temperature are having at least 10-degree or 15-degree delta between min and max. So let's say during the afternoons when you have maximum temperature at site, your turbine output will be decreased. Not only the output, but your efficiency will also, heat rate will also deteriorate. Then, I mean, people know that how it is going to change, but how exactly it is getting changed and what are the component of it that we will talk about in this video. So, if you see, there are certain different lines taken here. And if you see this one is exhaust temperature. So how your exhaust temperature is changing, you see that your ambient temperature is this side on the x-axis and output of machine is on the y-axis. So if you see your gas turbine exhaust temperature as it is increasing due to your ambient air temperature increase, the heat rate is also increasing. This line, the last in your this symbol, this one triangle, it is also increasing. So heat rate increase means what? Heat rate increase means uh, if heat rate increases means your efficiency is getting down. So as the temperature is increasing, your efficiency is getting down. And how your output? So this is your output, the circle. So where is the circle one? This one. So if you are having a output at 0 degrees Celsius this much, maybe close to 108.5, then your output will decrease to somewhere 42, 45, this area if the temperature is increased by 40, 45 degrees. So this is a, I mean, very high deterioration factor, which is because of ambient air. And the concept behind this, let us discuss that concept. So output is also decreasing. Output means the capacity or low max loading, whatever you want to call it. That is also increasing. Oh, sorry, decreasing. So why it is happening? So it is happening because gas turbine needs certain quantity of air to use that fuel to combustion and then draws output from that. So let's take an example where you are putting some X quantity of fuel and that fuel is, some T is your firing temperature, which is the max limit. Now, at the same fuel, let's say there is a, we can say Y amount of air was also there. So you are getting a T temperature. Now, let's say the ambient air is temperature is increased. Now what will happen? The same volume of air which was earlier pushed into turbine with X quantity of fuel to increase to maintain T temperature. Now what will happen? This Y will not go because in the same volume the air density has decreased. Density is decreased because of high temperature. So what is happening? Your Y quantity is not getting pushed at the same volume. So if your IGV is maximum open, compressor is trying to pull that maximum air of quantity, volume, then also this will be not Y, this will be something less. Now, if you are putting the only same amount of X fuel, then what will happen? Your T will increase. T will increase because the air is less. So what will happen? You cannot push that X amount. Now what will happen with the reduced Y? You have to reduce X also to maintain same maximum firing temperature. So as your fuel is reduced, air is reduced, what will happen? Your output of machine will also reduce. This is what is being explained here. A gas turbine is a fixed volume machine. You can use, a fixed volume of air through compressor and turbine. So when the air temperature increases, the density decreases. So that means the rarefication of air is happening, and net quantity of air which is pushed inside the turbine is low. That is why you will be able to push low fuel flow to maintain same maximum temperature. So that is where your output is getting reduced. Now output part, if you have understood, so there were two part we have explained. One is your output, power output, which is this one. So your output is decreasing. This we have explained. Now there is another factor for your heat rate is increasing. Why your heat rate is increasing? So what is happening if you calculate the compressor efficiency? If you calculate your compressor efficiency at this temperature, maybe 10 degree or 20 degree or 30 degree, so that compressor efficiency also has a impact of your air temperature which is being handled. So that is why your compressor efficiency is also decreasing with, increased air. So you see cold air increase that compressor efficiency. So that temperature factor is also there. If you want to understand how that, compressor efficiency is calculated, we have created another video dedicated to that. So you can watch that video. I'm not going in that detail. So that is already available. You can watch. So this compressor efficiency deterioration is causing your heat rate to increase, right? So there are two factors. One is your heat rate is increasing, means turbine efficiency is decreasing. Another is output is increasing. And you will find, I think, why it is happening, I have explained. But how much it will happen, for that you need to see your turbine manual and go to correction curves. For G make turbine, you will find that correction curve, and I think it is more or less 1.3 to 1.4 megawatt drop in output if you increase 1 degree Celsius of, increase 1 degree Celsius of air temperature, ambient air temperature. So this is what we wanted to explain in a very short and crisp video. If you still have some question on this topic, you can ask in comments. We will try to come back whenever we find time for this. Thank you. Thank you very much for watching our videos. Thank you.